Hello, welcome everyone to my space. It's Matthew Farrow here, and this is the first of possibly many videos in the Concoction Series. In this video, I will be providing solutions to these basic set theory questions. Let's get started. The first question, the problem one, is saying we should list the elements of the following sets: set A, set B, set C, and set D. This kind of description is what we call the set builder notation. And we're given a description of the following sets, and we're asked to find or to list the elements of the set. So to be able to do that, we need to understand what the set N and set P are. So the first one, set N, is a set as given to us 1, 2, 3, ... It's simply the set of whole numbers, the natural numbers. It goes on and on to infinity, countably infinite. And while the set of P is also an infinite set, it is the set of all prime numbers. So prime numbers, as we know, are numbers that have two factors, themselves and 1. So we have 2, 3, 5, 7, 11, 13, 17, and so on. It goes on and on. So then the next thing for us would be to decipher or to understand the description that is given to us in the set builder notation. So the first one is A is a set of elements of N. That's the first thing. So this symbol here represents elements of, so it means everything in A, they belong to the set N. So we have elements of N such that, so that colon represents such that X is less than or equal to 8. So it's a simple description. So the first part is telling us where should we go and pick the elements of A, and the answer is in N. Then the second part is which of the elements of N are we picking, and those ones that are less than or equal to 8. And that's all. So to list them, we also use our curly brackets, the braces. So we have 1, 2, 3, 4, 5, 6, 7, and 8. 8 included because it is less than or equal to 8. And that's how to interpret set builder notations. The second one is saying B is a set of elements of N. So the things that we expect to find in B are things in N such that they are odd numbers. X is an odd number. So unlike the set A, where we are able to list all the elements of A, in B there is an infinite number of elements. So because we have numerous odd numbers, infinitely many, and as such, what we can do is just to list a couple of them, and indicate that it goes on forever. So we have 1, so 2 is not an odd number, so skip it. Then 3, 5, 7, 3, 3 numbers are enough, then, because that generates a pattern already. And we say ... So I hope we know that this ... is not just random. So these are 3 dots that represent what we call the ellipses. It tells us that the set goes on forever. All right. Then the third one, set C. Set C is the set of elements of N such that X is greater than 3 and X is divisible by 3. X is divisible by 3. In other words, we are looking at N again, and we are looking for numbers that are greater than 3. So starting from 4, 5, 6, and so on. But not just greater than 3. There is another condition, there's another description. They are also divisible by 3. So they are multiples of 3. That's another way to describe them. So, and which numbers are multiples of 3? So we can write them, we can try to list them by saying, okay, these are 6, 9, 12, 15, and so on. And we can also just say this is equal to the set of 3z or 3t, whatever, where such that z starts from 2. So z is greater than, z is an integer that is greater than 2. Greater than or equal to 2. But essentially we have listed the elements. So the fact that we've put the 3 dots there means we're saying the list goes on and on forever. And finally, D is a set of elements of P. We are finally moving to the second set, element of P such that X is less than 10. So all we just need to do is to go to the set of prime numbers here and pick out those elements that satisfy this condition, though they have to be less than 10, and we have our candidates 2, 3, 5, and 7. And that's it. That's the end of the question. I think I will pause it here now.